Gives you the stability. The large diameter that you can get when you've got the bed bars on, up to 26-inch diameter. The ease of moving the tool rest beam around. They're on cams, so you can move them right the way out with a rod that goes to the floor for, again, stability. The 6-inch travel of the quill of the tailstock for drilling purposes. In fact, the variable speed from 50 to 2,600. In fact, the benefits of this beautiful machine are far too great to mention in this short period of time. It's just an all-round wonderful machine.
This is the short bed tailstock, which gives 24-inch between centres and 26-inch diameter capacity. The tailstock mechanism is a quick action lever which allows for drilling and boring very rapidly. When the work is mounted in a chuck or on a faceplate, the boring bit can be used to take out the centre, and the tailstock advanced, and a second plunge taken, and so on. Another function of the quick action arrangement is that if you have a piece where you're exploring different centres, say to retain a feature in a piece of wood, then this allows you just to nip it up in what you think is an ideal arrangement. If on rotating it you find that it isn't, you can just raise or lower the piece to find an alternative. Once this is locked off, then the work is held between centres. We've also made provision for a 5/16 diameter auger to be used in conjunction with the tailstock. It's bored through, and with a hollow centre in position, long hole boring operations can be performed. Once you've located the tailstock where you want it to be, it's locked and clamped by means of this hand wheel. This operates a tapered detent pin in this tapered groove, which ensures that the assembly is both locked and prevented from moving in and out, but also that the alignment of the centres is maintained perfectly. An additional clamp here provides for total security. When the tailstock is not required, you simply unclamp, release this hand wheel, and the tailstock body just drops out of the way and can be parked in that position. Initial alignment of the tail centres is by means of a twin tapered block, which allows the tailstock both to pivot, so that gives a lateral movement, and an eccentric portion which gives a vertical adjustment capability. When the centres are aligned, the nuts are locked off at the tail end of the bar and at the front of the bar. The tapered wedge then means that if the tailstock is withdrawn, it always relocates with perfect centre alignment. With the screw and clamping cap removed, the tailstock can be taken off, and you can see the taper arrangement here. This is an eccentric taper, and the mating half here is a concentric taper. That allows concentric movement of the tailstock body. This one provides for the vertical movement of the tailstock body. That allows for perfect centre alignment. This is the twin taper block. The mouth of the tube is machined with a corresponding taper so that it locks immovably in place when it's under tension. It's tensioned with this long rod which extends right through the bed bar. That's screwed into the back of the block here. So as the nut is tightened at the back of the bar, so the rod comes under tension and the tube under compression. It makes an extremely rigid assembly that allows the bar to be extended out to the full capacity without any deviation from its horizontal position. The bar itself is machined from 12mm wall thickness steel. It has a ground surface which provides a nice sliding action, and when it's withdrawn you can see the thickness of the tube itself. That is actually recessed counterboard to allow for the clamping plate to locate accurately. After machining and powder coating, the various components that make up the lathe are moved into the assembly shop for final construction of the machine. Each machine has its own history as it's progressed through the various stages of manufacture, including the running in process, which is a 9-hour cycle, various speeds. It's interesting at this stage we can see the main components of the lathe and how it's constructed. The headstock casting weighs about 300 weight. It's one piece of solid cast iron, stress relieved. It's designed so that the load, which is imposed by a very heavy overhanging weight here, rotating weight, doesn't impose any twisting force on the casting because the bearing housing actually extends back into the nose so that the load is taken directly over this large flat plate in a vertical plane. Similarly, at the back of the headstock, this massive casting ensures that the load is actually held in a horizontal position, and the forces are always directed in the strongest plane of the casting. Similarly, the cabinet base is constructed of 5mm steel plate to absorb all the conceivable turning forces that could be imposed on it. The plate here is sandwiched between the cabinet base and the headstock casting to provide the controlled thickness of recess or depth of recess that allows the beam to lock into it. The plate itself is laser cut. Here you can see tubes which have been put in to carry the wiring from the control unit in the base up to the headstock motor and controls. These tubes are 40mm diameter with a 12mm wall thickness, seam welded to the base here so that they can resist any combination of forces that could be exerted on them. The headstock itself is bolted onto this base assembly by means of these 12mm bolts which come straight through the cabinet base and through the center of the tubes into the headstock. Finally, before the headstock is actually mounted on the base, nylon washers are put on top of each of the posts, and then a rubber gasket placed on top of the plate to acoustically isolate the headstock casting from the base as far as is possible. And there we have the completed assembly. If you're not familiar with engineering and woodworking machinery, particularly wood-turning lathes, then this will give you an idea for comparison purposes. This is the main shaft out of an industrial Wadkin lathe pattern makers use, and this is one of the largest lathes made for wood turners. Just to give you the direct comparison, here's the main shaft of the VB. And you can see that there's a substantial difference in size and obviously in performance capability. This shaft would be supported in single row ball bearings, radial ball bearings, whereas the VB shaft is supported in these very, very precisely turned sleeve bearings, front and rear, which gives a massive area of potential support for the shaft. Each square inch of the shaft will support about 200,000 pounds of load before metal-to-metal contact occurs, and on this bearing alone there's something like 25 square inches of interface with the shaft. Similarly, the back bearing is designed with proportionate capabilities. This is the pulley which is fitted, and now we'll show you the complete assembly. We make a huge range of accessories for the VB, all purpose designed to enable you to do virtually any turning job that you can conceive. For conventional faceplate work, we make a range of 5 different diameters. The largest here, the 12-inch or 300 millimeters, is recessed. That recess fits the flange on the mandrel nose. This is the faceplate that we'll be using, and you'll see in a moment, to mount a 4-foot long log by 2-foot diameter without the support of the tailstock, to demonstrate the actual huge load carrying capacity of the VB in overhang mode. Smaller faceplates, this is the 8-inch or 200 millimeter. This one is about 160 millimeters and 140. And of course the 75 mil or 70 mil faceplate, which doubles as a screw chuck and the mounting body for the pin chuck. All of them are attached to the mandrel by means of these 3 high tensile screws, which virtually make it a part of the mandrel assembly. So there's no overhang, no flexing between the fixing and the work. Of course, we also supply a range of 4-jaw chucks in various diameters with the various jaw combinations that you're probably familiar with. If you have a tailstock, then of course you'll need centers. These are heavy-duty, large capacity centers on 3-morse tapers. This is a revolving center. Of course, you can use any other centers with the appropriate sleeve. If you don't have a 3-morse taper fittings at the moment, then this sleeve can be used to adapt what you have. For example, this is a 2-morse taper drill chuck, and the sleeve now converts it to 3-morse taper so that it can be used with the VB. Again, a range of different size drill chucks which enable you to carry various tools for boring and drilling. For conventional long hole boring for lamp flexes, etc., through the tailstock, we have the hollow ring center with a revolving nose that has replaceable, removable center points, a long and a short point. The counterbore drive center with a 5/16 diameter peg nose for centering on a pre-drilled hole, and of course the long hole boring auger itself, which in this case has been specially extended so that